Good morning, students. In today's class, we will start a new chapter, that is chemical kinetics. And in today's lesson, we will study about the rate of a chemical reaction, how to express it mathematically, and how to measure it graphically.
So chemical kinetics is that branch of chemistry that deals with the study of rates of chemical reaction. And what do we mean by rate of a chemical reaction? It means how fast or how slow the reaction is taking place. Not only do we study about the rate of a chemical reaction in chemical kinetics, but इस चैप्टर में और इस सेक्शन में हम ये भी स्टडी करते हैं कि वो कौन से फैक्टर्स हैं और वो कौन से कंडीशंस हैं जो एक रिएक्शन के रेट को अफेक्ट करता है, जैसे टेम्परेचर है या रिएक्टेंट्स का कंसंट्रेशन हुआ और कैटलिस्ट अगर यूज़ कर रहे हैं तो क्या इफेक्ट पड़ रहा है, और सम अदर कंडीशंस लाइक प्रेशर, वॉल्यूम एट्सेट्रा. So in chemical kinetics, we generally study about the rate of a chemical reaction and what are the different factors which affects that rate. That is a very simple explanation of what we study in chemical kinetics. Now, we have to understand what rate of a chemical reaction is, because we can't define it as simply writing like it refers to the speed of a reaction. That would be an incorrect definition of rate of a reaction. So how do we define the rate of a reaction? For this, let us consider a reaction phosphorus pentachloride PCl5 when heated decomposes to give phosphorus trichloride and chlorine gas. So in this reaction, what is happening? This is a general reaction. This is a very general example I am taking here, in which we have taken a reactant, and after the reaction takes place, we are getting two products. So what is exactly happening here? Initially, when you see the concentration of PCl5, you are taking certain concentration of PCl5, and after the reaction takes place, the PCl5 is completely consumed. इसका concentration after the reaction 0 हो जाता है. But we are getting two new things, PCl3 and Cl2. And that means concentration of the products. These are the products. The concentration of the products before the reaction was 0, and it starts increasing as the reaction proceeds till we get only products in the entire reaction sample. While the reactants, whose concentration were quite high before the reaction started, their concentration starts decreasing as the reaction proceeds to form the products. And ultimately, in most of the reactions, what happens? The concentration of the reactants reaches almost 0. So this is how we define the rate of a reaction. That is, the change in concentration. The change in concentration of either the reactants or the products per unit time. Change in what? Change in concentration of reactants और concentration of products with time. Means with time किस तरह से reactants और products का concentration change हो रहा है. Usually क्या होता है, reactants का concentration बढ़ेगा और products का concentration decrease करेगा. So this is how we define rate of a reaction. That is, change in concentration of any one of the reactants you are taking or any one of the products we are getting per unit time. So change in concentration of reactants or products per unit time. This is how we define rate of a reaction. So in this reaction, how will you define the rate of this reaction? Decomposition of PCl5, rate of this reaction will be equal to decrease in concentration of PCl5 divided by time taken. Or simply we can write rate will be equal to change in concentration, that is d concentration of PCl5 divided by dt. That is how we write. The concentration of any reactant or product is shown with the help of these square brackets. And d, that is differentials we are taking, it refers to the change that is taking place. Similarly, for this particular reaction, if we have to write the rate in terms of change in concentration of the reactant, change in concentration of the products. What are the products that we were getting in this reaction? PCl3 and Cl2. These were the products that we were getting. So rate of this reaction can also be expressed in terms of change in concentration of the product. So rate will be equal to, since the concentration of the products are increasing, so you take either PCl3 or Cl2, and so it will be increase in concentration of, either you take PCl3 or you take Cl2 divided by time taken. So that is how we define the rate of a reaction, or we can write this as d concentration of PCl3 divided by dt, or rate will be equal to d concentration of Cl2 dt by dt. So for any general reaction, if we consider a very general reaction, suppose we have AA plus BB giving CC plus DD. This is any general reaction that we are considering. Now what are these small a, small b, small c and small d? The capital ones refer to the formula of the reactants and the products. The reactants are A and B are the reactants and C and D are the products. But the small a's, they refer to the coefficients that we add while balancing a particular reaction. Say for example, if we are writing H2 plus O2 gives H2O. So to balance this reaction, we have to add half over here. So this half becomes the coefficient for O2. So in this case, in this particular case, small a will be 1 because there is nothing here in front of H2. The coefficient, that if there is nothing, that means it's 1. So coefficient in this case of H2 is 1. Coefficient in case of oxygen O2 is 1 by 2, and for H2O, the product, it is 1 again. So that is how we write the coefficients, right? So now how to write the rate of reaction for this particular general reaction? As we know, in case of the decomposition of PCl5, we have mentioned rate for this particular reaction will be equal to decrease in concentration. Decrease in concentration means the concentration is changing. So if you remember, we had written something here, decrease in concentration of PCl5. Now this decrease needs to be shown with the help of a negative sign. So here what we'll do, we'll put a negative sign here to indicate that the concentration of the reactants is decreasing, right? So this is the same thing we are going to apply here. Rate of this particular general reaction will be equal to minus 1 by A. The coefficients have to be taken as reciprocals. Minus 1 by A, d concentration of A by dt. So for this reactant A, if we want to write the rate of a reaction in terms of one of the reactants, so one of the reactants is A here, and so we will write it in terms of A. If we are writing, the rate will be this. Similarly, in terms of B, if we are writing, the rate will be expressed as minus 1 by B into d concentration of B, because B is a reactant, so its concentration is also decreasing with time. So if in terms of B we are writing, then the rate will be expressed as minus 1 by B into d concentration of B by dt. Similarly, for either of the products, if you see, rate will be equal to 1 by C. Now here there will be a positive sign in prior to 1 by C, the reciprocal of the coefficient, because the concentration of the reactants, the concentration of products are increasing during the reaction. So we have this d concentration of C by dt. So if we are writing in terms of the product C, then rate will be expressed like this. Similarly, in terms of the product D, we can write it as plus 1 by D into D concentration of D, capital D referring to the formula of the product, divided by dt. So this is in terms of the reactant D. So you have to remember, rate can be expressed either in terms of the concentration of the reactants, or it can be expressed in terms of concentration of the products. Any one of them, not all of them altogether, just one of them. So this is how we express the rate of any chemical reaction. Next, we have to understand how we can plot the rate of a reaction graphically in terms of reactants or in terms of products. For this, we have to keep in our mind that while a reaction proceeds, the concentration of the reactants decreases while the concentration of the products increases. So we plot a graph with x and y axis, and on the y axis we have to plot the concentration of reactants, and along the x axis we have to plot. Now initially when the reaction has not started, the concentration of the reactant is very high. So we can mark it with a point here on the graph like this, and as the reaction proceeds further with time, the concentration of the reactants falls, and so it can be represented graphically like this till it becomes almost zero or becomes negligibly small while the reaction progresses and comes towards an end. So with reactants versus time, the nature of the graph is like this with a negative slope. And how do we calculate the rate of a reaction using this graph? Rate will be equal to, for that we have to take 2 points on this graph. Say suppose this is one point where this is a rate, this is the rate of a reaction, and another point you have to choose. At this point A suppose, and this is a point B. So at this point, if you draw perpendiculars on x and y axis, you will get R1, and this is time T1. For B similarly, we have this point corresponds to R2 and this point corresponds to time T2. Now it's quite clear that R1 will be greater than R2 because initially the concentration of the reactants is high, but T1 is less than T2. Okay, so how do we calculate the rate from this reaction? Now this difference between R1 and R2 is dx, that is change in concentration of x, and this difference is the change in time, that is dt. So rate will be equal to dx by dt. That is how we express the rate of a reaction graphically, and this is called as average rate of reaction. This mathematical method of calculating the rate gives us an average rate of reaction. And so rate of reaction can actually be calculated or measured graphically by two methods. One is this method, which is called the by which we get the average value for the rate of reaction between 2 points A and B here, as in case we have seen here, A and B are the 2 points, and we are averaging the rate of reaction between these 2 points, and this gives us more or less an average value for the rate of the entire reaction. Similarly, we can also calculate the rate of reaction at a particular instance. So suppose if we want to calculate the rate of reaction at point A or at point B, so what would be the precise rate of reaction? For that, we need to find out the instantaneous rate of a reaction. So how to measure the instantaneous rate of a reaction? That means how to measure the rate of reaction at any given point, taking any concentration of the reactant under observation. So for this, as usual, as we had plotted a graph in case of finding the average rate of a reaction, we'll simply plot the graph with all the data that we have by calculating or by measuring the concentration of the reactants at different points of time t. So when the reaction is proceeding, all we have to do is we have to take readings for different values of concentration of reactants with each passing time. Say at an interval of 10 seconds, we keep on measuring the rate of the reaction. So every 10 seconds we have to note down the observation in the form of a table, and then we'll plot the graph using those observations. That is how we get this graph. And the graph shows a decreasing trend of the concentration of the reactants as we had discussed earlier. So to calculate the instantaneous rate, that means let us take a point P. At this point P, we have to calculate the rate of this reaction. In that case, what we have to do is we have to draw a tangent. we have to draw a tangent at this point P, and then we have to complete this right angle triangle by we just draw a perpendicular on this tangent. Just draw this perpendicular on the tangent. So now this corresponds to a reactant value and this corresponds to a concentration of reactant value. That means this will be dx, and since this corresponds to a value for time and this point also corresponds to a value for time, so this will be dt. This angle, suppose it is theta. To calculate the instantaneous rate, that is rate at this point t, at this point P, all we have to do is to calculate the slope of this tangent that we had just drawn. So slope of this tangent, we have to focus on slope of the tangent, and slope of the tangent is given by tan theta. Tan theta is perpendicular by base, and what is the perpendicular here? Perpendicular is dx divided by base, the length of the base is dt. So the slope of this tangent drawn on P gives us the value for the rate of reaction. So slope of the tangent, which we generally mark it as m, so slope will give us the value for the rate of reaction, dx by dt. And since it is a negatively sloping curve, so rate will be showing a decreasing trend, that is minus dx by dt. Decreasing trend, the negative sign will only show that the slope is decreasing, and hence the rate of reaction also shows a decreasing trend along with the concentration of the reactants decreasing over time. So these are the two methods by which we can calculate rate of reaction graphically, but you have to remember one thing here, that in order to plot the graph we have to take the readings first, and the readings have to be taken at certain regular intervals of time, say within a gap of 10 seconds or within a gap of 20 seconds or within a gap of maybe 1 minute, 2 minutes and so on, depending upon how long the reaction is taking place. If it is a very fast reaction, you have to take faster readings. If it is a very slow reaction, then the reading can be taken over a span of time with greater intervals between the two readings. So that is how we have to we can write down the rate of a reaction. In our next class, we will discuss about the different factors that affects the rate of a reaction. That is, what are the nature of reactants that can affect the rate of the reaction, and the concentration of the reactants also have a great role to play, then temperature and catalyst. So these are the 4 factors we will be discussing in our next class. Thank you everybody.